Let's take a quick look at derivatives and forming tangent lines using derivatives. First, we know that when we have some function that we can take a look at the tangent lines of that function, and we know that the slope of the tangent line is the value of the derivative at that x value. And we also know that as the tangents line come around, they have to hit 0 at relative max and relative mins before they switch signs to become negative. And then they come down, and here 0, positive, positive, 0, negative. And so we have three ways of talking about derivatives. We call them derivatives, instantaneous rate of change, and we also refer to it as the slope of the tangent line. And so what we're going to take a look at is setting derivatives equal to a specific value, and that's going to be what they tell us, or if they tell us they want a horizontal tangent line, that means we need the derivative to be 0, and so we're going to set it equal to 0. So for this first one, it's find all the points where the graph has a horizontal tangent line. So what that says to you is that we need f prime to be equal to 0. So let's find the first derivative. Derivative of x squared is 2x, of negative 3x is negative 3, of 3 is 0. And so we're going to set this guy equal to 0, 2x minus 3. Add 3 to both sides. Divide by 2. And so at the point 3 over 2 slash put in the y value, you are going to be able to name that as the point at which there's a horizontal tangent line. Now you have to go in and find that value. You're going to substitute 3 over 2 back into the original problem here and get a y value there. For this next one, find it where the tangent line to the graph is horizontal. So again, we're looking for this. So let's take the derivative, f prime, derivative of x cubed, 3x squared, derivative of negative 12x, negative 12, derivative of 2 is 0. We're going to set this equal to 0. Let's go ahead and factor that, x squared minus 4. So that gives us 3x minus 2, x plus 2. And so x is equal to 2, and x is equal to negative 2. And the 2 comes from this factor, the negative 2 comes from this factor. Find all values of x where we get that, and that is going to occur at these two x values. And so the key to these are to take the derivative and set it equal to whatever value it is they're giving you a clue for. Here, when it says horizontal, you set it equal to 0. For this one, for this function, we are trying to find the points at which the tangent line has a slope of 1. That means we need to set the first derivative equal to 1. So let's take the first derivative. Derivative of 13x is 13. Derivative of negative x squared is negative 2x. We're going to set it equal to 1 this time. Again, because that's the slope of the tangent line we're looking for. Let's subtract 13 from both sides. Divide both sides by 2. And we get the value of 6. Now, they are looking for a point. Here, find the point or points on the graph. The tangent line has a slope of 1. And so you need to go find this y value, f of 6. I'm going to leave you to those y values. Go substitute them in here in the original problem and get a y value for that. Find the points at which the graph of, and here's a function, has a slope of 4. Now, so we've had slope that's 0, slope that's 1. You know, they could tell us horizontal, lots of different things. On this one, they want a slope of 4, so the derivative is set equal to 4. And so take the derivative, set it equal to 4, divide by 2, and that's going to occur when x is 2. you need to go find the y value. We'll do this real quickly. 2 squared is 4, so that's going to occur at the point 2, 4. So we've got lots of problems where they're actually giving you the slope and asking you to find either the x's or they're asking you to find points. Be careful of what it's asking you for. These kind of problems can change to be find the equation of the line as opposed to actually just getting points or an x value. They want us to do this at x equals -4, so that means we're going to take the derivative and then we're going to evaluate it at -4 to get the slope. So let's take the derivative. F prime is, derivative of x squared is 2x, the derivative of -3 is 0. Let's evaluate that derivative at -4. That gives us 2 times -4, which is -8. So the slope of the tangent line is going to be -8. And we know we can write the equation of a line if we have a slope and a point. So let's find the y value for x is -4. We're going to put -4 in here, square it, that's 16. 16 minus 3 is 13. And so we get 16 minus 3, 13. Now we can do this two ways. We can use y minus y1 equals slope times x minus x1. That's a popular way. Other students will go and use y equals mx plus b to find the b. Let's go ahead and substitute the y in, which is 13, equals the slope times x minus the x value, so plus 4. Y minus 13 equals -8x minus 32. Add 13 to both sides. -8x, excuse me, 13 is going to give you 20, 30, yeah. And we're adding, so this is a negative here. That is the equation of the tangent line at x equals -4. So we went and found the slope by substituting it into the derivative. That's the slope of the tangent line. We got that. Then we go ahead through and find the equation of a line. We can do this with a function that looks like this, a little uglier. We're going to do what we did last time, only with x equals 2, and that's okay for this to be ugly. Let's rewrite it. X squared plus 3x minus 1 to the -1. Now when we take the derivative, we get 2x minus 3x minus 1 to the -2. Chain rule out is just a 1. Let's rewrite that. 2x minus 3 over x minus 1 squared. Now, we are looking for an equation of a tangent line when x is 2. And so the slope of that is going to be the derivative evaluated at 2. So we need to put 2 in here. So let's go ahead and do that. Y prime of x is 2. So we get 2 times 2 is 4. Minus 3 over 2 minus 1 is 1 squared is 1. So 4 minus 3 is 1. That is telling us that the slope, and we can write slope or m, is 1, and we're going to use the point 2 comma, let's go find that y value. And to find the y value, we have to substitute 2 back up here into the original. And so let's do that really quickly. F of 2, you get 2 squared is 4, 3 plus 3 over 2 minus 1, so we get 7. Sorry, that stylus is really cranky. And so that gives us then this slope and this point. Now let's go find our equation. Y minus the y equals slope times x minus the x. So y minus 7 equals x minus 2. Add 7 to both sides. X plus 5. This is the equation of the tangent line at x equals 2, which is what they were asking us to find. So again, what we need to write the equation of a line is slope at a point. How do we find the slope? In calculus, slope to us means derivative, slope of tangent line, instantaneous rate of change. And we needed a specific x value, so we're going to take the derivative, leave it as it is, rewrite it, substitute your value in for x. When we do that, 2 times 2 is 4. Here we get minus 3, so we get 1 for the slope. And then go find the y value for that x that you're looking for. So you get 4 over 3 minus 1 plus that, and that gives you 4 plus 3 is 7. Now we go back to algebra class. You can use this or you can go find the b. So that's it. Hope you're having a great day.